Okay, so Master Mason note coming out here. Excuse me. Yeah, COVID. I figured I would do a note on what it is, what it isn't. Now, this is something you've heard before, and you might get a few Zenzingers out of this one, but we're going to go ahead and find the physics. Okay? So when I say describe what the physics is, when I say you'll have the physics, I'm going to show you what that represents. We can use an air turbulence equation real quick. I think we're generally pretty good with the 0, 1 on the first part, the matrix that it makes. And what 0, 1 is in here, before we get into any heavy-duty topics about this, is a subset of what this is as it's doing something or a mechanical action in what you're doing. Now, when you think about a hurricane or this standard air pressure or this standard air pressure, topography, conditions somewhere else, and a map that says it definitely does that 2 or 3 times, then in that form, for the way it's being described, works to that first equation. Here, it jumps right into that second one. Generally, however, an operation where you need to use this tool in several different ways on several different nuts becomes that general form of the matrix. It's a good fishing tool. It's good for doing obviously mechanical things, fine tuning, little pincers. It serves that purpose in short of the way the air turbulence equation works, or the way the universe works. What's this distance? Now, mathematically, you'll have this problem as well, because as mathematicians, I think you have to look at the whole problem, and let's make a form for this. The problem with mathematics is that generally this distance is not this distance. This distance to you, to me, is arbitrary to whatever we're going to put into it. We could say that distance over there, that tree between this, and any kind of divergent ways, that original type of mathematics of just this symbol, E equals, you could say E 100 per, E N100, maybe, I don't know, K equals 100, N1, N0, whatever. And yes, it definitely does. It acts like a wave function. It acts like a particle. So in wave particle function calculus forms to steel, it's going to tighten into other variables on the skid steer safety for the mill form, because serviceabilities change. You don't rationally test that form of it. It's not commonly described technically as a teaching aid to do it in that form, because there's usually not a lot of follow-up in the mechanical process that follows fixing saws, cars, an environment that gets ready to house a chemical experiment. That distance is arbitrary, because that distance is general relativity. So the other problem with that, with some of that inherent mathematics, that it's not going to say a lot of people, one, a lot of them are dead, Newton, they're not here to ask, 2, busy, 3, in terms of a common described model, they're all over the road. You can find any equation off of any equation. You have to be able to. It's not a question of, is it there? It is definitely there. But in the general limitations, what is the shadow problem in this form? Because it gets to the point sometimes in math, because you just got to be like, you're going to do it like this. It's going to look like that fucking happy bush. And unless the laws of the universe describe why this landscaper's company is planting trees, rose bushes, or anything else that would have to be mechanically perfectly sound, by the weights of that rose plants, the placement of where you push it, how it distorts an EM field on my home life and business, bro. And so, as a common everybody, go figure. So inside of it, you gotta take your train equation, right? Train A, train B works in joules. It's this train versus that train. The same train, they move in the same thing. Are we old? Who was it, J.P. Morgan back in those days, deciding which trains to go? What person in the engineering crew line of A and B train to be able to describe why you have Euler's number in a setup like that, why you have number grafting, compounding systems on timelines, Like, because one operation might take several days with one operation inside of it, and then sometimes you have to recreate the whole experiment to find better yields on those things. Once you get your little dually jobber all work together, you can find a faster, better way, more efficient from those parts, because now you know how to use this thing a little bit better, and it's going to make that go a hell of a lot faster. So again, you should be able to get there from any equation. All that's on the board. Now we unify that, because the stone mill is going to be your example at the end of the day. We got to break that down, because some kids, you just have to have a high volume. I don't know the initial Agent 47 for your parents model from birth to, and which similes you have. I have to build that, and it's, you know, over time, one a day, right? One in the bucket's going to add up to over an 18-year-old every time, but that doesn't always necessarily add out. It does, but those are quantifiable to different timelines that, again, most people don't track. I don't track them. You probably wouldn't track them. Parents wind up tracking them. People do it for their dog all the time. It's like, no, that dog can be OP, and that's on the top end. You can do that with some crew guys. You can do that with some players in the militia, local town meeting that we just, I don't know, fuck it. I just wanted whatever they were doing. I wanted a piece of the action. You know, I get a say in this. Yeah. So that's that arbitrary length, you know, and then from that you should be able to say, all right, well, on this A and B train, what's dark matter? All of the potential frames that could be made of this mile an hour on this train, and we'll fix this one at 1, and we'll say that it's based in 0, but all these moves do a different way. And once we fix 1 or 2 of them, then we can get into, you know, topography, altitude. You want to add a dimension on a hill that changes some work in joule and change it to the output of fuel instead of just the time. And where's the cutoff on that? Is that inside of this always, because it always makes it there regardless, or some asshole at the train station forget to load it up with coal and just send it out there? Because where does that play off in the universe and all of its infinite things that it does? Because they got dark matter too, and it's like they got lensing effects, they got horizon problems. This whole thing at that point in time, as soon as you said, I got that gremlin, his ass was just sitting on those rocks staring at me, laughing, just laughing at me, and I'm like, you know what, this whole mill. And then you go through and you wind up doing some things with the system that actually bring crew around in the office. You sit them all down. What was your problem with him? I guess he needs to be in here, and you need to say it just like that. And I need to be in front of me, so that way it makes happen like that. Because when it comes back around on my fucking ear, I don't get paid psychologist time. Catch you on the next one.